Select the best reagents to accomplish the following transformation. In looking at this reaction, we want to identify the functional group of the starting material and the functional group of the product. Looking at the starting material, we have a carbon-carbon triple bond. So this is an alkyne. And we should also designate where that alkyne is. So an alkyne at the end of the chain, such as this one, is known as a terminal alkyne. If that alkyne were within the chain, it would be known as an internal alkyne. If we look at the product of this reaction, it is an aldehyde. So there's a hydrogen that is understood to be there. So the way that we take alkynes and form carbonyl compounds is by adding water across an alkyne. And so we have two different conditions to add water across an alkyne. One is shown in A, which is acid, a strong acid like sulfuric acid, mercury sulfate, and water. This would give a Markovnikov addition of water. The other option that we have for adding water to an alkyne is to follow a hydroboration-oxidation protocol, such as option B. And this is the way to have water adding across an alkyne in an anti-Markovnikov fashion. Looking at the two carbon atoms of the alkyne, the end carbon atom where you have a hydrogen is the less substituted carbon atom. That's where we see the water, the alcohol has added initially an enol, which then tautomerizes to this aldehyde. The hydrogen appears to have added to the more substituted carbon of the alkyne, which means that what we have here is an anti-Markovnikov addition, and we would want to select the hydroboration oxidation conditions shown in B.